Morning, everyone. So yesterday's last class, professor told you about all the models. So everyone is clear on that, like maximum strain energy model, distortion energy model. So let's start from the exercise problem. Is everyone clear in this review call? Like maximum shear stress model, maximum strain energy model, or maximum distortion energy model? If all are clear in how the von Mises is calculated and what is the von Mises stresses respect to maximum distortion energy. This was your last lecture by Professor Lin. So let's come to the first question. We'll solve it together. I think that will be more good. So maybe you can note down the question. A small part of the shaft is to be investigated as shown in figure. The shaft is under the loading of bending moment M equals to 500 Newton meter and a twisting movement or a torsion of 600 Newton meter. The material of shaft yield of 250 megapascal and an ultimate tensile strength of 500 megapascal. Endurance limit of 200 megapascal. Poisson ratio is 0.35. The diameter of the shaft is 30 mm. We have to answer these following questions. So first, determine the principal stresses. For this, you have to use these equations. This question is done in the class? No? Then you can start doing it. Let's start. Find out the first principal stresses. S1, S2. For this, you have to find out first the sigma and tau.
Will the equations be given in the exam?
No, maybe. It depends on the professor. Because exam paper will be set by Professor Lin.
I would told him to give. Maybe.
But you have to see only the final equation you have to mug up. Just remember the equations. But for today, I've just put it in one slide to make you can have the equations. Maybe first you note down the values, then I will move to the second slide where the equations are there, so you can just have one by one. First, calculate the sigma and tau value. Everyone got the question? What it is? You have a simple shaft where we want to determine the principal stresses, safety factor, which one is smaller or using the maximum shear stress model. Then we have the same question with the maximum strain energy model, like all the models in one question. So one problem with solution with all the models, and we'll find out that which model is more conservative or which model is the more fittest. Have they divided into groups? Already groups have been divided.
Already.
So for the tau, you can use for sigma 32 m by pi d cube, and for the tau, you can use the equation 16t by pi d cube. Finding sigma and tau. So everyone got this answer? So this is the solution for sigma. You can use 32 m by pi d cube, where already the value of bending moment and d is given, the diameter of the shaft. And for the tau, 16 t by pi d cube, already the top value is given in the question. Then you can draw the more circle. Now find out the S1 and S2 values. Ignore this is some mistake I have not deleted it. Don't use this three values. can also check the values if I am wrong.
Why do you have to multiply by 1,000?
Because that's a megapascal. You have to convert the unit. Newton per meter unit. Yeah, that's right. It's millimeter square. So convert it. Just for conversion, we have put in the marks. How was your last exam? Was good? So everyone got this answer? Now find out S1 and S2 values. For both the principal stresses, you want tau max. For finding both the principal stresses, you have to find out tau max. This one? So in this way you can find out the S1 and S2 directly sigma by 2. Already the radius you find out 94.315 plus tau max value. You can, in either way, you can find out with the equations also.
The access can use an equal to sigma y over s.
Yeah.
1 minute.
You can use it in that stage. Answer is different.
0.867.
You use which equation? For MSS, you're talking about MSS. Same with tau max by also you can use. 6.8. Only the two values. That's very good. Yeah, it's almost. Because if we consider full equation, all the values may be very same. In this, there are many methods of doing it. You can use simplified version or you can use your own version from the equations. So your first problem was to find out the principal stresses, and the second safety factor will be greater or smaller than what using MSS. So in this, first we have to find out all the S1 and S2, the principal stresses, and the second part is you are using maximum stress energy. You have to find out the safety factor. Now the same question you have to use maximum strain energy model. So for maximum strain energy, you have to use this equation, this one, and put the values of S1 and S2. You will find out the safety factor. This is distortion energy, MDE. I'll correct it in a second. Fourth one is distortion energy. Don't worry, I'll share you this solution after this. You doing it? Already done? Oh, two is not there. Yeah, there is some mistake. There is no two. Yeah. Okay. This two is not there. You have to use this equation for distortion energy model.
the model ND?
Yeah, it's MDE.
Professor, excuse me. I came late, but I still have to ask you because I don't understand. Why is the S2 evaluated in positive sign, even though the result was in negative?
Which one?
The 53.015. That was
It's a square. Here, yeah, that's right.
But in the second part,
In the second-
where it's multiplied by the Poisson ratio.
It's whole squared minus.
Whole-
But then the second one is not whole squared.
Oh, the second one was.
Yeah, because the second one there's no square, so keep the negative. But then if you square something negative, this one then
That's for the first. The one that is. The other one. Yeah, minus 2 Poisson ratio is 1.
the number 3, second line.
This one,
Yeah,
should be
exactly.
negative.
it should be negative.
Yeah.
It should be negative.
Yeah.
And correctly. So this is all your third question using strain energy, and the fourth one is using distortion energy. Now, everyone got that answer? Based on second and third, which model is more conservative? You have to find out. Based on two, that is stress energy, maximum shear stress model, and maximum strain energy model. Which one is the most conservative? Which one?
Maximum shear is the most conservative.
Okay. So for MSS, like MS was less than or equal to 0.4848, so it is the smallest, so MSS is the most conservative. Then the sixth part is the design is safe. If not, the yield strength should be greater than what in order to reach the safety factor of 2. So already your safety factor is given. You have to find out using the maximum MDE. Use MDE in this problem. So if there is not safe condition, use this value, create sigma and find out the sigma y value. So everyone got till here? Practice this question, maybe similar type of question can become tomorrow's exam. Okay, can you move to next? Next, already I have shown you where on the online lecture we made W3 equals to W4. That's why the torsion value is 0. That I have corrected in the slide. Now we will make it W3 and W4 like a similar, have a different values. So your torsion will not be 0. You have to find out the reaction forces, shear movement diagram, first loading position, Mohs circle, principal stresses, maximum shear stress at first loading position. This is the same what we have done in the previous classes or previous lectures. Then adding to it, to the previous problem, the shaft diameter subjected to 6000 Newton meter of torque, and the maximum bending moment already we have find out that problem. If the yield stress is 10 Newton per meter, Poisson's ratio is 0.33, Young's modulus of the material is 25,000 Newton per millimeter square. You have to determine the vector safety using all these theories. There are more two theories like principal, which I think Professor has not told you, principal strain theory. So only you use 3-1, don't use 5. Whatever taught in the classes, you use only 3 models: maximum shear stress, distortion energy, and strain energy model. Okay, don't go write 5 and compare 3 of them. Which one gives you more conservative? So the same problem we have to do it from the first beginning till the last, till this class. It's the last lecture of all these models. So it will be a huge problem. So then you can check that which model is most conservative. So you have to find out from the past, from the reaction forces to till last. This problem we'll do in the class. Let's start from the reaction forces. It's the same problem which we have already done in previous classes, but I only changed that in that class W3 equals to W4. That's why the torsion value was 0. But here the W3 and W4 is different. Find out the reaction forces at the B and G. Start from the calculation of the reaction forces at point B and point G. both the directions, in the y direction and the z direction. Okay, the first step is summation of all the forces in y direction equals to 0. Then take movement about any of the reaction points. That is, I'm thinking about the gy. This reaction points equals to 0. So the force acting here into the perpendicular distance till this point. In this way, you can find out the both the reaction points or the reaction forces. Similar way in the g direction. Summation of Fg, all the forces acting in g direction equals to 0. Then find out the moment about the Vg or any of the point. So for g direction, we are find out the moment about this point. So all the forces acting in g direction in perpendicular distance about this point. Everyone got the reaction forces? If you want, you can just simplify also. If you want, make this figure into simple directions like this. Your f of dy. Make it into line diagram. It will be more simple to solve it. Make this into line diagram of in the y direction in the g direction. Yes, like this. A point, B point, C. This is your simple diagram. So it will be more easier to visualize. Now the second part is find out the shear force in y direction and also find out the bending moment in y direction. Because the pulley at EF provides you the uniformly distributed load. So here we have to find out the position of the O. Because the maximum bending moment occurs when the shear force is 0. So you have to find out the position where the shear force is 0 and the maximum bending moment is maximum. In the professor's slides, already you have seen that he used like a mathematical form, but you can directly calculate from the similar triangle rule. The answer will be same.
They use this.
Yes.
They use
Okay.
this.
You'll get the same answer. You can see that the G shear force at G is start from 0 and till the right of the G. It's just before right. You will get 451 because the reaction force is here in the center. So it will be a line. Then comes to the F point. Everyone got this? Shape force diagram. Let's calculate the bending moment. Draw the bending moment diagram. So in this, we can observe that where the shear force is zero, the bending moment will be the maximum.
What was the shaft radius?
Shaft.
Yeah, the shaft radius
Diameter was given already in the shaft.
for the
35
for
mm.
the tower.
35 mm.
Get the okay.
Already given that.
That's fine.
Similar way, you can find out the shear force and bending moment in the z direction. Have you decided your project work? Your group? You have not decided? Anyone? Any of the group has decided what we will do in the project proposal? No?
Teacher didn't.
Oh. Maybe in the next Wednesday's lecture, we'll get like two of our projects and display the AMR, and maybe we can get the real-time stress analysis, how what we are doing it. You can take any of the component from that AMR and do the proposal on that same component. Hope everyone reached here. Have you drawn this? Steven? Also calculate the maximum moment at the point O, where there is a shear force as 0.
Is that supposed to be like segmented for the, like from x equal 55 to 20? because where does it stop at 12.305?
Yeah.
Yeah, isn't it a straight line?
No, it's a bending moment.
Yeah, but
It's a
the,
straight line here.
because you integrate the shear, right? And the shear from that point to the,
From 0 point.
from B to D
Yeah.
is like linear.
From the B to C. But what you're talking it's a shear force. It's a different. Now
Yeah. But they're related, right? Like the moment is from the integration of the shear.
but the moment is linear, but at the point B, the moment will be 0.
And then, but then,
Then you have to find out the point C. The movement will be like the force acting on the B into the perpendicular distance.
but why do we need C? Because there's no force at C for the y direction.
No, we are just calculating it at every point.
Oh,
So,
so
so the diagram will be clear. Otherwise, you will directly from here, you will get to here. But the difference will be there.
because
This part maybe in the center also you can check.
isn't this a Because this is the shear, right?
Yeah.
And this is a straight line. And here's the 200, which is equal. So if you integrate this, doesn't it just become a straight line here? And there's no like stop from here to here.
But if you calculate like C, the distance is changed. So at C will be always different. The movement at each point will be different.
Correct, but it would be in the same linear line. It wouldn't be a
Maybe you
break.
can do it. It's okay. But I just make it point wise. So it will be like when you draw it, it may be a similar.
Yeah.
Similar linear. Because the value will be maybe a similar linear. You're talking about like this.
Yeah.
Can you explain how do you get that point B? Can you explain how do you get the moment at point B?
I don't.
Can you explain how do you get the moment at point B?
Point E,
B.
point D. This point. We are calculating the moment at point D from the end point. What is the force acting on? Will I change the values? Maybe the same PPT. Now it's clear. The force, we are taking a point moment at D. The force is from here to the perpendicular distance till D is the 5 plus 50 plus this 20 plus 80. The force acting on the FGY 451 into the perpendicular distance till D, this point D.
Why do we include 80 and 90? Because 80,
This one,
yeah, but it's supposed to be the force.
force acting at here. I'm already calculating at this point D, before the pulley.
But just in the Z direction, we calculate in the Y direction.
Yeah, the Y forces into perpendicular distance till D.
Yeah, but
The force acting in the Y direction till this distance.
I was confused here.
But
If why did we put 80
this is for any moment. That's the moment. The moment at the point D. But it's, if you doesn't want to calculate this, okay, you can directly calculate at this point. But I have calculated at each point.
Yes.
Yeah, this force, and this force related to this moment. That's why it's negative. This force into the perpendicular distance till point D. You can, like this is the force acting at GY. Now, if you want to find out the moment at the D point, not at the pulley, because here the sources are acting in the center. Because it's uniformly distributed just before D, just before the load. So this force inside pulley will create a distance of this much. So here is 5 plus this 50 plus this 20 and this 80. 451 the force is perpendicular distance. But if you are segmented, like here till here, only this much area, then you'll get it. Because this is like we are using a till C point. It's the same. But when you minus from here, like if you have suppose you are at this point I'm calculating this and read this point. Not this much. That's why you calculate at each point. If you want to eliminate, you can also eliminate. If you don't want to read this one, it's all. But this is a point where at D here. But because it's a very linear, it's the same, so it will be like this. So no need also if you want to eliminate, you can eliminate you get these 2 points. That you should get. What's his question was like this. So it's not necessary to calculate at each point. But what I suppose to I calculate at each point. That's why it's a break. But if you don't want to calculate, just you will get a big error. So this area. So 4,550, 451. here this is different. 20 minus x is like 0.09, yeah. Just you calculate with area rule. This one is 5.91. This should be negative. Thank you so much. No, it's okay. Because here we make it negative. This one. I think that this one will be negative. Yeah, this we are using here plus negative. There is no positive. Till here. Should you can check this one is correct. X1 value is correct. This then, see, if you calculate from this side, it's coming similar. Why from here? Oh, this will be 55. Yes, this will be the center. This one 55. You can run 55. Here it is actually the center, but you are calculating 451 into 50. It will be 55 plus 5. Until here, yeah. Plus 32, the load acting here, this is 32. Total acting on the center, 10 to 10 plus 8. Center. The uniformly distributed load is total is 32. Distributed in the 20. So it will total load will be distance into the concentrated loads. So it will be total load will be 32 into 20 plus it will act in the center. From center to the distance. It will be like 10 plus 8. Yeah. So it's like we are like I just used to calculate it like perpendicular distance. The force into distance. It will be easy to calculate at each point. Why I calculate in point wise? Because I think you only chosen only two type of loads. One is the uniformly distributed load, and another is the concentrated load. Like this is the concentrated load acting on a point, like reaction forces. Another is the uniformly distributed load, like Newton per meter, suppose x Newton per meter. So if x, like x Newton in the span of area. So this is uniformly distributed load like in pulleys. But there are some many loads. You have seen this one, uniformly varying load. This is UVL, uniformly varying load. So for this case, this is another different. So that's why majorly when I solve the problems, I solve it into point wise. Because if there is some uniformly varying load, you have to calculate at this point and this point. Because both are different. Here the load will be almost zero, movement will be zero. But here the movement will be there. So in this way, your bending moment diagram, you will follow a curve. It will not be a straight line. It will follow not will be a linear line. It will be a curve.
I have a question.
But
What
not
is
in
the
this
formula? Oh, about this, everything is okay. But what is the formula for the torque? Because on the slide you wrote down that it's like the result is 6,000, but I used the previous formula and I
2 into S1 minus that was.
like next slide, like the next one, where there was all the results. Next, um, yeah, up there, why do you write 8 times 20? Because I thought it was 2 times 20 because there are 2 pulleys. But why is it 8?
Check it up again. No, in the last problem we have made it. It's 2 times I think. No, that would be minus 8.
Yeah, there again, you it says 6,000, but I think it's 1,500 because instead of 8, it's 2. I'm not sure.
No. It's W1 minus W2. W3 minus W4. 8 is.
Okay.
Yeah.
Oh, okay.
Yeah. The torque is like for the only this one is your W3 minus W4, that will be 8 into
Okay.
total diameter. Yeah.
Yeah, 20.
Reflecting and this pulley.
Yeah,
It's sharp. And this is
Right.
your diameter by 2.
yeah. Okay.
Then you will get 6,000.
Okay.
That's why I was. In the last problem, because both the value W3 and W4 is same, so that was 0.
Mhm.
That's why torsion was 0
Okay.
when we are calculating in the all line. That's why I corrected it. If in question there will be given like W3 is equal to W4, then the torsion will be 0 in that case. So everyone got the bending moment in Z direction? Shear force in Z direction?
Yeah.
And find out the point at which the shear force is 0. That's point P. Then you have to find out the maximum bending moment at point P and point O by considering each of the y direction and g direction values. And find out the resultant moment. Resultant moment at O and resultant moment at g direction. So whichever will be the higher, that point will be considered as the maximum bending moment point. In this, like maximum bending moment at the O point, we have to consider the O point maximum bending moment in y direction and in g direction both at the same O point. So here I have calculated the maximum bending moment OA in y direction. Already we have calculated in the y direction equation. Then also in point OA in g direction. So it will be here. Then we have to take the resultant of this movement. So this is the resultant movement at O. And similarly, in P direction, we have to calculate the bending moment in G direction and in Y direction, both at point P. Take the moment, whichever is the higher. Like if the O point moment is the higher, consider O as the maximum bending moment point. Don't be confused. This is like I'm not using any of the mathematical equation. I'm just making a small calculative way. You also can use what the professor has taught you in the equation wise, but the answer will be same. You'll get the same maximum and minimum point. Here you are just calculating like the effect of at O point in both the directions and the effect of at P point in both the directions. Movement at P point in both the directions, taking resultant. calculate the value of sigma and tau and torsion at point 2. So for calculating torsion at O, this will be W3 minus W4. That will becomes a A into the length of this pulley, that is 20, into the total diameter by 2. Because the question already it's given. Both the diameter of the pulley is 75 mm. So here you will get the 6000 Newton per meter. Now calculate the sigma value and tau value. Then you can get the tau max and S1 and S2, like principal stresses. So now you get all the values which are required for all the models. Then draw the Mohr circle diagram. Now calculate all the three models. You have to find out the factor of safety, the N value. You can use like maximum shear stress model, this one. Then calculate the strain energy model, factor of safety, then distortion energy model. The three models already Professor told you, so use three models. If you want to consider, you can use another two more. Because there are total 5 models. The name Rankine is because they name it as the inventor. Then you have to compare all this factor of safety and check that which model gives you the best FOS. So it will be like maximum shear stress theory, but in realistic, everyone uses distortion energy model, that is von Mises. So the next step was like after finding all these values, next step you have to put all these values in each of the models and find the N value, that is factor of safety. Everyone got how you have to solve the problem from the starting to all these three models, which finding the most conservative model.
That shows the other formulas for the other two models. And the last one.
I'll share this like make a video and share in the group. That's better.
Okay.
And you have to find out like make it a summary table. Just put all the values of factor of safety and just show it that which one is the most conservative. And you can note down these are the 4 more problems which you can try and solve. These problems are very simple. Just use one model which is mentioned. Like here is one masses means you have to use distortion energy model. Here you can use maximum theory, maximum shear stress theory, strain energy model, and principal staining. Maybe this you can eliminate, but the 3 you can do it easily by considering all the equations which is given in the list. Maybe professor will give you the equation, or maybe not. So you have to learn or mug up this basic equations. Maybe after your ANSYS class, there is one more lecture. After that, you have to all the groups. You have to find out some, I think, proposal presentation,
Not yet.
but already in the schedule.
Like maybe October 15th.
October 15th.
Yes. It will introduce the example.
Yeah. I will introduce the examples of mechanical design. After that, maybe you can find out which one you have to use for your proposal. Like we have 2 AMRs. Have you seen our AMRs? Have you not seen? Want to see? Maybe you can take them to the Industry 4.0.
Yeah. Oh. Okay. I'll ask teacher.
Yeah. So maybe in the next class, after the class, maybe we can visit Industry 4.0. There you can, or I'll show you first here that both of the AMRs, how we can, whatever you have learned in this course, how you can implement in the AMR, which part you can consider for your proposal, like the chassis or maybe the wheels or maybe the shaft, and make some analysis on that and show the results. Maybe you can change the material and show that already what the work our student has done. Maybe you can improve it on different way. So then in the Wednesday's class, we'll see that one, and after that you can consider which part you want to work on. So your group can decide that which component you have to present the proposal.
Do you have the assistance though?
Where?
The QR assistance though?
Oh,
Yeah.